All right, I think we're live. Yeah. All right, good to have you here, guys. This is the second workshop of Moonbuilders. Super excited to have Greg with us. So Greg is from ChainSafe. If you don't know ChainSafe, you probably, like, I would say 95% sure that you have used some of their amazing tools that they developed, but probably you didn't even know. ChainSafe, they're behind Web3 JavaScript and also ChainBridge. And Greg is CTO in ChainSafe, and he's gonna talk today about ChainBridge because it's a really nice bridge solution that we are actually implementing in our tested Moonbase Alpha. So with that, I'll let you take it away, Greg. And thanks a lot for coming into the workshop.
Yeah, no, for sure. Thanks a lot for having me. As Alberto said, we do, I'm one of the co-founders and CTO at ChainSafe. And as of right now, for those in the Polkadot space, you might know us from the Gossamer implementation. So we built the Golang implementation of the Substrate. We're syncing now, so soon you'll be able to have Go support in the Polkadot ecosystem, and as well as Web3.js and Polkadot, as among other node implementations that we do in the wider blockchain ecosystem. And yeah, so today I'm here to talk about ChainBridge. I don't know my slides. Oops, 1 second. Application window. Sorry about that, guys. Yeah, so I'm here to talk about ChainBridge. ChainBridge is something cool. We're up and running. Is a solution that we've built over a couple of years now of building bridges. And basically, the high-level idea of ChainBridge is it's a way to facilitate the movement of data across multiple different blockchains at the same time. And I'll get into that a little bit further. And we're going to go through the presentation with just a high-level overview of kind of give you an understanding of what ChainBridge is. And then I want to dive deeper into basically giving you guys like some actual real use cases that are being deployed today, and also use cases that you can use on the test nets so that you can understand like why it makes a lot of sense to actually go and use ChainBridge with Moonbeam. And also, while I'm talking, feel free to ask me questions. I like being interrupted, so I'll be always monitoring the ask a question section, and when it makes sense, I'm going to hop off out of my conversation and answer the question and go back and forth, because it's good to make this as interactive as possible. So let's kick it off, kind of a little bit of ChainBridge 101 and kind of like what's going on, how does it work? So the high level, first things first, ChainBridge moves data between two different blockchains. So basically you need one or more blockchain, or two or more blockchains. And in this first one, we got two blockchains. And we have this piece of software that we built. So this is kind of an off-chain piece of software. Anybody that's familiar with oracles will know that oracles feed data, external data from a blockchain into a blockchain. Similarly, we have this external thing called a relayer. And this software is in charge of reading events from a blockchain, reading the state, things that are changing on one blockchain, and bringing that or relaying that to a second blockchain. Within the ChainBridge system, we have many relayers. Many relayers work together to facilitate this, and this is how we try to actually build some redundancy into the system. In future iterations, build further decentralization and trustlessness. So let's look a little bit deeper and understand some of the components. Again, I don't want to go too technical unless somebody actually has a question. Otherwise, I'm going to try and gloss over so we don't get too stuck in the weeds here. So basically, what's kind of going on and what are the properties here of ChainBridge itself? So on the blockchain specifically, right now we support all possible EVM configurations, assuming there hasn't been anything crazy that's changed. That's how Moonbeam's actually making use of us. We also, if you're in the Substrate ecosystem, could leverage a palette specifically. So we have built a Substrate specific palette. And working on a few other implementations down the road and other ecosystems such as like Cosmos and such. So that's how we get our data and feed our data back into chains, is through either EVM or Substrate. We also have an admin. You can get rid of the admin at any point in time, and you can actually get a little bit more fine grained in roles and responsibilities if you choose to. And then on the relayer itself, so this is the off-chain piece. We kind of have three main components. The connection, which effectively just like bridges us from chain A to whatever, so we can actually see it. We have a listener, and this is sort of like the first line of defense. This is where we first see that, okay, a user has made some sort of a deposit or has made some sort of interaction that we need to do something with. And then the listener takes that, mutates the data, and then gets it ready for the writer. And the writer basically says, hey, there's another blockchain, and that connects to a different blockchain, then basically says, let's go fire it off. And we'll get into that a little bit further. When will, I don't know what that question is. Cool. A little bit deeper. I kind of just did cover this. So basically, again, like the idea is like we have two blockchains here. We could have as many blockchains as we wanted. You know, white and yellow here are the two blockchains. And effectively, we're just passing data between them, sort of like how a router would route data between, you know, your house and the wider internet, right? And as we can see, basically an event gets fed into this listener. The message gets converted into a payload that's usable. And then, you know, we do some transforming of the data to make it compatible depending on the chain, right? So depending on it, you know, the chain might have specific properties. If you're going to substrate, it's not, doesn't look like the EVM. And then we rewrite back onto the destination chain and make a new transaction for it. And yeah, so basically what's actually going under the hood. On blockchain A, you know, a user is calling a method, an extrinsic, a whatever, depending on the chain type, called deposit. And really what deposit does is it deposits a message. In most cases, and where we've seen ChainBridge deployed the most and the most used for is ERC like tokens. So like ERC20 tokens or maybe NFTs. That's where a lot of our usages come from and where people really make a lot of use of ChainBridge. And where I think you'll see a lot of activity on Moonbeam Bees, especially for things like DeFi, if you want cheaper access on gas and things like that, which is going to be great. And basically a user would go and deposit this token. So let's say we have DAI, right? The stable coin on Ethereum, it gets deposited. You can deposit it on Ethereum. The relayer then picks up that event and says, whoa, I saw that a user deposited it, transforms the data as accordingly, and then basically says on the Moonbeam side, hey, I'm going to write and credit this user DAI, right? And that's what's happening. You get this like kind of like fake DAI. It's not really the actual original one, but it's basically represented exactly as it should be. And what's happening is really there's some accounting. So on the Ethereum side, we're basically locking it up and it's in escrow. And the thing is the bridge holds it in escrow until it comes back through the other side. And this is to ensure we maintain total supply and that there's no funky changes. And I kind of jumped ahead a little bit into this one here a little bit. So I kind of explained effectively that. Let's talk a little bit about security and kind of like what's going on under the hood. Again, I'm going to get to some more deeper examples a little bit later and we'll go into there and can get questions. So basically the on-chain components are effectively multi-sigs right now. And with future iterations, I kind of remove this into a different model. But for now, basically, there's a multi-sig on chain. For those that don't know multi-sig, it's a sort of the idea that you need a certain amount of votes to then pass, and then an action can occur. And basically, the relayers act as the multi-sig holders. And so in this case, we have trusted multi-sig holders, people that people that have some sort of reputation, and they're in charge of signing off. Depending on how it's deployed, it could be a 2 of 3, 3 of 5, a 1 of 5. Really doesn't matter, but it depends on your deployment. And that's how a messenger happens. So basically, what happens is when a deposit's made, that initial votes goes in with a proposal saying, hey, like this user wanted to move 10 DAI over. And then the other relayers go and basically are just checking off, basically saying, yes, the data does match. Yes, the data does match. And eventually, once we hit that threshold, the transfer is completed and the user is credited. In this process, accounting for block confirmations, because we have to make sure we're reorg safe. So that's chain splits and stuff like that, depending on the type of chain. It can a transfer takes, roughly speaking, about 2.5 minutes on the lower end, and depending on how the security model looks, it could take upwards of 5. But 2.5 minutes is definitely on the shorter, quicker end there. Click. And one of the other interesting properties that Alberto and I were just talking about earlier, actually in the green room, was basically something that ChainBridge allows you to do, which is a little bit different than some other instances, is that we can actually connect to multiple blockchains at the exact same time. So, I'll use testnets I'll use actually real live ChainBridge instances as an example. If we wanted to, we could bridge Ethereum mainnet, Ethereum Classic, and Avalanche all together and have them all connecting to one instance of ChainBridge. And this could actually operate really smoothly and seamlessly all back to Moonbeam, right? Moonbeam connect to these 3 other blockchains. We're basically bridging 4, and the same 3 relayers are operating. It's a nice property because it gives us the ability to hop around. The other thing that's great about that is if you were to move DAI from, let's say, blockchain, one of the blockchain A to blockchain B, and then you move that same DAI to blockchain C, now you've got DAI that's moved between 2 chains. Traditionally speaking, this would be a little bit challenging. We've set it up so that basically if you want to go from C back to A, you can actually do that and redeem the exact token that you think you were going to get. It wouldn't create some new one. You're not getting like some funky variation. You get the original one that a different user might have deposited originally. So you get some nice guarantees there. And yeah, as I said, okay, so that was the high level overview. I guess this is a good time to just basically I didn't go too in depth. I didn't want to hopefully didn't confuse people as is, and I didn't really want to go really confuse people on more in depth. Anybody does have a question about the operation of it, security, trust models, or anything, now's a great time. Otherwise, I feel free to interrupt me at any later period.
Well, I'll take a shot at a question, Greg, and I think we were also discussing this, some time ago. Is that this is a nice image. I think the explanation is super great because it's very graphic, and I think a lot of people like graphics explanations, right? But I do see a problem, and that you only have 3 layers, right? 3 relayers, right? So even though there's a multi-sig, you still have kind of a centralization problem, right? So how efficient it is to have a lot of more relayers to create a little bit more decentralization versus the economic incentives that the relayers will have to pass.
Yeah, for sure. That's definitely one of the more challenging things in the initial V1 kind of ChainBridge. So basically, right now, the way it works is whatever that threshold we've described. So the threshold is effectively what makes quorum. So that would be 2 of 3 relayers vote and a proposal is passed. Right now, in order to pass a proposal, it's threshold plus 1 transactions, which isn't great. It's a little inefficient. So that's a gas heavy optimization. So that's why we've reverted in our V1 iteration to basically say, having a trusted set, 3 to 5 typically is more than adequate relayers that are well known and have some reputation at stake. That way, we can account for that the higher gas fees that are incurred in this iteration, and reduce the threshold that's needed. Now we have other versions that have upwards of 80% gas cost reductions, and also combinations of how we've combined a few different functions together to ensure that instead of having threshold plus 1, it's actually quite lower transactions to move the proposal, so that we can actually start increasing the relayer set and arguably getting to a point where even perhaps other random people could join in with a little bit of stake, which is great. But in this current iteration, like I said, we're at this situation where 3 to 5 is good. I would say anywhere from 2 to 3 yes votes. So the threshold being set there is where you're good. And that's a redundancy factor at this point, right? And then from an economic standpoint, we can charge a fee. It's a static fee for right now, but it can change. You can manually change that over time, assuming gas costs kind of crazy and stuff. And that's a fee on the deposit. So basically, the user would pay this fee to make this transfer of whatever data it is, and then move across the bridge.
Sorry, I was finding the mic button. So and is this fee split between relayers, or is how is it go to the relayers? It's just divided by the number
so
of
the
relayers?
fee actually itself isn't divided by the relayers because we can't actually have a guarantee. It's up to the holder. So as we said, there's like this available admin. Usually we deploy a multi-sig against the admin, and the relayers are then run a multi-sig, or someone else might be in charge of that. And the fees just sits on the bridge and then can be dispersed however chosen. The reason we do that though is because sometimes we'll find that if we have 5 relayers and let's say our threshold is 3, 2 relayers might not actually be doing anything. What's done sometimes is they're actually use those redundancy nodes, and in case of 2 of them fail, and they trail behind the other. They put a longer block delay, so block confirmation delay, so that they trail and are basically sitting saying, okay, wow, someone really didn't vote. 20 blocks later, I'm going to come in now and clear that out and make sure this proposal gets moved. And that's why, so it's manually dispersed that way.
So there's like a higher lag in the transaction, let's say, or people have to wait a little bit longer, but at least they're sure that the transaction will go through, right? So
so that's why sometimes we add those extra relayers, and we just say trail a little bit further behind and just sweep stuff as it comes by in case there's sometimes high gas causes transactions to fail. You know what I mean? And then it spikes back down.
And what about another question I had right now with our conversation is, what about like imbalances in fees, right? So if it's not the same to move something from Ethereum to Moonbeam, let's say in the future, than from Moonbeam to Ethereum, right? So I mean, there's a little bit of an imbalance there. So if you charge a flat fee, how is this cost covered in both ways, right?
Yeah, I know for sure. So that's definitely a challenge, right? And the challenge is you're taking a fee in one currency and I said currency, and paying and effectively making a transaction in another, right? So, in the event that, let's say, we have a lot of people going from Ethereum to Moonbeam, right? And not many people going back because for whatever reason, Moonbeam makes a lot more sense for them, gas fees and all, whatever else. The relayers have taken a lot of fees now in ETH and probably paying a decent amount of fees on the Moonbeam side. But again, with price changes and stuff like that, this initial iteration really doesn't cover fee structure as like one of the selling points here. And it's tough, it's difficult, and that's
no, definitely. I mean, it's I'm like doing questions about running, and you're just like learning how to walk, right? So it's kind of difficult. Yeah, definitely.
Yeah, I mean, we're playing with ideas of using oracles to kind of set like more, in the MakerDAO system, for instance, there's like a 1 hour time interval of basically when the price of USD gets updated. Right, so that vaults don't get closed or get liquidated really like in crazy ways. We're playing with kind of similar ideas on a shorter intervals of basically saying, what is the exchange rate between these two tokens, and can we actually set a more dynamic fee using, maybe we use like a Chainlink oracle or something like that. And that's a good point. That's a bit more of an appealing way. And we're definitely looking at different options on how to do this more efficiently. Because as we've seen a rise in usage of ChainBridge, it's definitely getting to a point where, proving the concept that we can move multiple assets across multiple chains at the exact same time is done. Now we need to move to decentralization and economic incentives. And that's kind of where our next, as you said, we're crawling still, and you're out here running.
All right. Yeah. Thanks a lot.
Yeah. Cool. So that's kind of the bridge there. And so as I said before, right now, ChainBridge offers kind of 2 supports right out of the box, EVM and Substrate Palette. So that's Substrate native, a little bit different. Moonbeam is deploying the EVM contracts between their chains, which is like honestly just as great in my opinion. The Substrate one is a little bit, more involved, but EVM, a lot of stuff out of the box, which is great. And I can't click. Oh, wrong button. Oops, there we go. Yeah, so I'm quickly going to put some bridges in production before I start going into some like use cases, just to show that this is show you kind of what's out there, and say if you wanted to play around, kind of get a first glance at just, other stuff outside of the Moonbeam ecosystem, it's there, but also to show you that we have battle tested this, and I think that's something that's probably worth that'll be great. So right now, one of our earliest partners was Centrifuge. They're a substrate-based chain, and they do some NFT kind of based stuff. It's been running now. We're closing in on a year with really no issues at all, which is awesome. So they've been running and operating for quite some time using the NFT-based transfers. And our bridge kind of sits right in the middle of their stack. I think this is actually in their architecture diagram from like their docs, and we're right nestled right in the middle. The other one is the ETC bridge. This one was set up, it works, it operates, a little bit on the less liquidity side, but it works flawlessly. We're running it and it's running smooth. And then this is our biggest deployment of ChainBridge actually to date. So for those that are familiar with that Avalanche or AvaX team, we basically currently the contract that holds all the funds and locks the funds on the Ethereum side is holding over 120 mil USD. And I think as of today, I rechecked the numbers. I think we're actually at a total volume transferred. So this is like total volume moved, not necessarily locked, because some people might have moved it in and then moved it back out. We're over about 350 million now USD of value transferred between the bridge. And this has been running since early February. Again, without a hitch, it's been going really smoothly. So if anybody was worried about, moving their stuff, and if you want to really test it with high value, feel free to have a look here. But once the Moonbeam team has it up and running and operating, like full steam ahead, like let's get some stuff moving, because I'm telling you, so far so good. Cool. I didn't change the title on this. That's really funny. Okay, so I'm going to get into some examples, and I want to talk about some like a little bit different use cases than like just tokens, because tokens are really easy to understand. But I want to talk to, for the developers out there, I think what ChainBridge does offer, we have a little bit more unique features than, you might see right away. So basically, to highlight, we have three main functionality. We have one main functionality that then with two kind of abstractions is how I'd like to say it. So basically, ChainBridge is an arbitrary bridge, right? It moves data arbitrarily. It doesn't really care what it is. It just transforms that data to meet the requirements of the destination chain. So there's like an origin chain and a destination chain. The thing that is interesting here is that because it's arbitrary, we've built two basic examples. So we built a base ERC20 and an NFT, a ERC721, the most basic versions of each kind of token, as an example of like how we would move assets from one chain to the other. But what really is the really fun part, especially for developers who are looking to make use of automated tooling, perhaps better UX from their users on Ethereum. Maybe like you want to hide the fact that you're using an L2 or a Moonbeam in this case, right? And you want to just make use of like really, really high, really like a cheaper gas fees or whatnot. Or you want to play around economic incentives. You can use the arbitrary data notion that exists within ChainBridge to actually execute arbitrary transactions, and also basically control things completely in a completely different manner than like you would normally think. And I'll give a really great example. So imagine we have a DAO imagine we have a DAO, and this DAO, let's say, processes a few thousand votes per day. For whatever reason, they're very active. If you do the math on that, that's going to be really expensive to operate on something like Ethereum today. And let's say, you're like, okay, well, Moonbeam, those 1,000 transactions are going to be really effective for us. Like, I'm going to definitely go to Moonbeam. This makes sense. We should operate. And this isn't like to discredit anything, this is purely for an example. Let's say you're just like, I don't know if I want to put my whole treasury on Moonbeam just yet. Moonbeam just launched last month. Maybe I'm going to give it like a few months. I want to keep my treasury in Ethereum. What do? This is where you can make use of ChainBridge. And basically, you can have ChainBridge operate in between, where the multi-sig could live on Ethereum and the DAO itself could be living in Moonbeam. you're doing all these transactions, and let's say a referendum happens where you are saying we need to move a large sum of cash from a large sum of whatever the asset is from the multi-sig to a new address. That can actually be facilitated completely through the bridge, effectively in a decentralized way to submit a transaction from Moonbeam. The DAO can say, okay, hey, we finalize a proposal, and it, when that last vote hits, that like causes the quorum to be reached, it sends a transaction to the bridge, to the deposit function. That then gets relayed across the relayers. The relayers pick it up and then write it to the Ethereum mainnet and say, hey, I have a transaction, like a valid transaction that was signed by this DAO. Now go and execute it on Ethereum, which is actually going to go and unlock the funds to the multi-sig, because the DAO on Moonbeam actually owns the multi-sig on Ethereum. It's a little bit complicated. It might be hard to wrap your head around initially, but like this is what's available to us and available to be done cross-chain, right? And this like really unlocks the whole idea of like doing cross-chain transactions. And in this case, the user none of your users would ever actually have to leave the, let's say, Moonbeam MetaMask network, which is a huge plus. You're executing transactions on Ethereum and never leaving Moonbeam. It's an interesting concept. Sorry, a few questions just came. Oh, no, we're good. Yeah. And another one I'd like to highlight, I think I actually got the wrong slides in here. Another really cool idea I want to highlight is more in DeFi space. And maybe some of you might actually understand. This might be a lot more straightforward to you. Something that the bridge can be done is to facilitate the onboarding into Moonbeam a lot easier at the beginning. So let's imagine that, let's say LPs start spinning up on Moonbeam, and, we've got some DEXs, maybe like a Uniswap style DEX running, and we have to fund some LPs. Well, it's probably not super intuitive if I were to tell you, well, okay, in order to do this, you have to bridge over, that's one transaction. Then once you're on Moonbeam, you're going to have to go and sign like probably another 2 more transactions to kind of facilitate the whole idea that like, bridged, then you got to approve your token, and then you got to stake the token, and in order to do this LP, you're not just sitting there like clicking buttons, and that's not the greatest UX, or, maybe for your dApp, not the greatest idea. But what if I could tell you on Ethereum, you could click one button that says like stake into LP, and what actually happens is very similar to the DAO idea. We're basically one transaction deposits, and then when you get to the Moonbeam side, it automatically will go and enter the LP position on your behalf, right? And these are all the sort of things you can start unlocking with cross-chain functionality, so that now your user, one click, is already in Moonbeam. Now they don't have to like do anything, right? It's like, cool, I'm now collecting rewards. They change networks, maybe redeem some LP rewards, or whatever it might be from that position that they've in, or that DeFi position. And this is really where the fun really part can unlock, is when developers start getting really advanced functionality to basically say, how can I improve the UX of going across 2 different blockchains, which is fundamentally the big problem we have today. Right, is like it's really easy to get in, but then we're scrambling between MetaMasks, or we're scrambling between networks, or worst case scenario, your users only use a hardware wallet, and perhaps there isn't hardware wallet support yet for your chain. You can get all the interactions, get them fully set up, and then have them only interact that way, right? That's some of the really cool stuff you can unlock by just doing generic message passing. So it's this idea of just like arbitrary payloads with pre-made transactions executing across networks on your behalf in a decentralized, in a more trustless manner, right? And as we move the bridge to a more trustless manner, this will be unlocked even further and further.
Yeah, I think that's just to make a point there. I think that for me was like the breakthrough moment when I was reading about ChainBridge, that it is a message passing protocol, right? And the ERC20 and ERC721s are just like handlers that are specific applications of this generic handler. And when Mia and a coworker were playing around with ChainBridge, and we used a generic handler to do something very simple in Koban, like write a string, or like set a Boolean to true, but you can actually see how powerful this is. And its applications are basically limitless. I mean, there's limitations like, the gas limit per block and stuff like this, and how much are you willing to pay, and this kind of things to do that action. But it's really amazing and exciting to see that it's like if you would have a sandbox, it's like ideal, because like you can do so many things and to play around with so many features, right? So one thing that I was discussing with the project, back in the day was like, would it be possible to, it's even like a little bit more complex of this kind of like examples that you presented. It's like, let's say I live on Ethereum and I execute an action that goes to Moonbeam, let's say, and I do all the gas intensive operations on Moonbeam. And then by the end of those operations, I send back another message, right? To let's say, set a Boolean to true, meaning that the transaction was already concluded or whatever. So, I mean, this back and forth is also possible, right? With this ChainBridge configuration.
Actually, something, yeah, that's actually something really, really interesting. I wasn't sure if the mute button was still or not. Is that basically like you can sort of create this feedback loop, right? Because all you have to do is at the end of the life cycle of whatever that first transfer was, it just has to make another deposit. And as long as you make one more deposit, you can start like looping back and forth, like you were saying, which is awesome. And I mean, like, there's so many applications to that where it could make sense, a very high level, perhaps a DeFi token, perhaps there's some mass DeFi operation, some crazy thing that goes on. And, it gives you some token to say that like some NFT or some token or something that basically says like, you have ownership over this. And let's say for whatever all intents and purposes, that token is most widely used on a different network. You could actually, in theory, and this is where it starts getting like very, we're almost going Inception here, but like the idea is like, let's imagine that there's an NFT, right? And let's say, or some NFT token for like LPs, okay? And, I'm on Ethereum. I like one click stake my tokens into this Moonbeam LP. But let's say on the Avalanche chain, that's where like that actual like LP token is most valuable. In the same kind of round, I can actually send it. I can like one transaction on Ethereum can actually execute the transfer to Moonbeam and then also move that LP token to the Avalanche network all in one go. Obviously, like that's kind of a bit crazy. There's probably the cost of it would be really high, but it's what's possible, right? And that's what, as like for developers, I really want to stress is that you can start getting really creative. You have to be a little bit gas in mind in that instance, obviously, but there's like endless possibilities at this point of making UX better. And I think that's as we see a rise in different chains coming up and different offerings, it's like, that's really important, is thinking about the UX of your user moving between them. Because, we've been doing this for a while. We launched the Gurley testnet, for those familiar, back in like 2018. And, our joke was like, wow, it's really hard to get people on here. So we did a 2-for-1, you put in one testnet token, you get 2 Gurley tokens, and we would burn them. But the point of that was to show like the UX is just like bad. And we were seeing that back then. And, it's not that the UX is terrible now. It's just, as a dApp developer, it's not just about moving the token from one chain to the other. It's about, can you actually build a fluid interaction from one chain to the other? And I think that's where, so we're going to start seeing some really, really cool stuff, and ChainBridge really helps you get there. I do have some like kind of pre-made questions here as well, if there's no questions from the audience. Yeah, there's the thing. So I can get to those in a sec, unless Alberta, you just want to ask me them.
Yeah, sure. This is actually a question that it was funny because I was biking for whatever reason in a mountain bike. And I was like, oh, what about, I don't know, it's this kind of questions that just pop in your mind. And it's because you're familiar with the ERC 677, right? So this is the standard that Chainlink uses for the link token. And when I was reading about it, I kind of understood that it's basically a token that you can do a transfer and call, and then, set some other like action, right, that you do through the token. So would it be possible to create like instead of, creating like an economic model that is based on this ERC 677 token, and then, you know, use that as a you know, economic incentive to move the bridge and incentivize and basically run like the gas for the bridge?
Yeah, it's definitely an interesting one. I think it's probably possible. It's
because I feel that's like, you know, I feel that's how Chainlink like solved the problem of like incentivizing nodes and all these kind of like players in the game, right?
Mhm.
So I kind of understand like this V1 of ChainBridge was more like, let's get the message protocol like running, working, and let's set a feed model so like it's simple that it works. But I wonder if this could be another like layer like you can put on top of ChainBridge and say, hey, can we make like a fully enclosed like solution that has its own economic fuel or whatever?
Yeah, no, for sure. And I think that's totally possible, right? Because I think the general gist here is that, you know, 677 reduces the amount of calls you need to make, which is great because that's good for the user. But I'm trying to think. So something that I guess actually something I didn't understand is transfer and call is just transfer plus approve, right? Where would the economic reward be there?
Well, I mean, my understanding is that in the Chainlink token, you have like a payment set that when you like, you know, when you execute an action, you can put a payment that it's ran through the link contract, right? So I was just curious if like you had any other insights of like if it was possible or not, because my understanding is that transfer and call, it's actually executes a subsequent call after, you know, you run that function. So
yeah, okay, I see what you're saying. Yeah, no, and that's the thing. Yeah, like in theory, like when that initial mint happens on the destination chain, yeah, that could be totally a payment thing, right? Like the bridge could automatically say like, hey, I'm just going to charge like a small little token of gratitude, so to speak, and that could actually be done on every token, right? In theory, like we could do that for every single token because it's backwards compatible too. So if an app doesn't actually need 677 or isn't traditionally or a token isn't traditionally 677, we can still upgrade it to the 677 protocol on these other blockchains while maintaining, you know, the same kind of system. Yeah, it's definitely actually a very novel way to do it and probably something that would work.
That's cool. Yeah, and another question that I thought about is that it's regarding NFTs. So I guess you know this one as well. Is that NFTs is a pretty hot space right now. It's you know, it's moving quite crazily, and you know that regarding NFTs, they have like different, I don't know what's the correct name, like plugins, add-ons, right? That, you know, like you can deploy a simple NFT and you can have like a metadata kind of like add-on. And so what is the NFT that is supported by ChainBridge and how many add-ons? So like what else is supported besides like the core NFT contract?
Yeah, that's actually probably worth discussing, right? So there's probably a big differentiation here. So as Alberto mentioned earlier, we have this notion of handlers. It's this idea. It's like it's like we need a contract to handle the arbitrary data, right? So we have an ERC20 handler and we have an NFT handler, 721 handler. Now with the ERC21, we're actually very fortunate because ERC20 is always the base implementation for every ERC20 token. We actually are able to, can deploy what we call a synthetic token. So like, you know, it's not originally from this chain. And we can deploy kind of anything. So for instance, there was a bridge instance that deployed the Chainlink token as a basic ERC20 220 implementation, which was everyone was like, "Ooh, this isn't good," and it was solved really easily actually because we were able to just deploy a 677 version, and it still works with the original handler. So that's a really great benefit that we have with the ERC20 stuff. When it comes to NFTs, it becomes a bit more challenging because the specification for NFTs are constantly changing. I believe like the new de facto like base implementation is like 11 something or like 1024 something like that. It's in the 1,000, right? And
it could be 1155. The one that is like the general token for all.
Yeah, I think that's the one. And I think that's like the new base NFT one. The current NFT one that we have, the handler, it assumes it's effectively a to, a from, and a metadata value. So unless like this new NFT doesn't actually needs more than that, then we would actually probably have to redo the handler. Fortunately for us, we haven't been in a situation like that because everybody's been able to use that. And also NFTs weren't really as popular as they are a year and a half ago.
Well, and I mean, I think also like handlers are neat because they offer like straight away like you can adapt. It's like straightforward, right? You have a handler for an ERC20, so you can get started more or less fast. But at the end of the day, like we mentioned before, ChainBridge is a message relay or protocol, right? So you can always like go to the general like generic handler, and like your specific token use case can use the generic handler at the end of the day, right? So.
Yeah, and I guess that's a really good point too, right? Not to make things scary for developers out there. If let's say you have your own handler, right? You're like, wow, like I want to decode this data in a very specific way. Like you could deploy your own handler and develop your own one. It's actually, depending on what you're doing, it could be anywhere from like 10 to 40 lines of solidity. And the only hard part is assembly. So if that's a little scary, we have a lot of good examples of how to do it for ERC20. So you can get a very clean example. And yeah, like the contracts aren't complicated, I guess is what I'm trying to say. It's like you can both get creative on like the call data side, but you can also get extremely creative even just on the handler side. If you're like, hey, I want to like do something very specific with this arbitrary data and it doesn't fit the mold of what exists already today, it's totally possible, which is great. And I guess that's also another thing is this idea that this arbitrary call piece, right? All the examples I gave were the notion of, hey, there's like an arbitrary execution, right, of this transaction, that arbitrary data handler. In theory, right, you can, like a handler is really just, the whole concept is just handling that arbitrary data. So let's say due to permissions of the bridge, maybe like your handler isn't like approved right away, or you can't get that implemented right out of the gate, which is, it is definitely a thing. You can use the arbitrary data handler that's set up by default to just call your own custom handler, and we can start getting really nested and start going down a rabbit hole there. But I guess the gist I'm just trying to get at is like, it's very easy to work with. And we've been trying to make it, because ChainBridge is more of a framework for us rather than like a standalone, like it is a product obviously, but like the idea is like it should be a framework for you to build whatever you want. And I think, as I keep saying, especially with NFTs and, a lot of this DeFi space, it's about the UX too, right? It's like, hopefully we can build better UX.
Yeah, definitely. And I like what you mentioned, that it's a framework, right? So the idea is that people build on top of it and just not leverage whatever solution there is. So definitely.
Change it.
Yeah.
Change it.
Yeah,
break it, change it. Yeah. Oh yeah. Yeah.
I actually have another question, and this is a question that a lot of projects have like asked us about our implementation of ChainBridge. And actually, if you go back to like this very nice diagram that you had with like blockchain A, blockchain B, and relayers in the middle, right? Like whatever, like, yeah. So let's say, for example, that, I mean, my understanding is that, and this is actually for the people to know as well, is that you would have, let's say you have DAI on the left-hand side, right? And you want to have DAI on the blockchain on the right-hand side. The problem is that you'll have to have a contract on the right-hand side that will mint this new DAI. Let's say that it's a wrap DAI or whatever you want to name it, because it's just a name, right? So the problem is that on the left-hand side, you will either have to lock the token or burn it. In this case, probably because it's DAI, will lock it, right, in a vault contract. So what is the difference between like locking, like is it more efficient if the contract on the left-hand side, the tokens are burned and then are mint on the right-hand side, or is it just depends on the token that you're moving, or what's the difference between locking and minting or burning and minting?
Yeah, for sure. That is a very good question, and can get a little complicated. So we have this notion of an origin chain or a home chain. And then we have this notion of destination chains. So basically, an origin chain or a home chain is where a token was created. It's where the inception was, and it's where the circulating supply really started from, right? It's where like the main circulating supply is. So if you have a weird token that, mints more of itself like over the course of the year, and it was deployed to Ethereum, and then you deployed maybe it a couple other times, but there's no minting functionality on those chains, its home chain, its origin chain is Ethereum. And in that case, that's always going to be a lock. We're locking the token or we're releasing the token. The reason being is because ChainBridge doesn't own it. And if ChainBridge doesn't own it, we don't have the rights to actually create new like more of that token. That'd be a terrible thing. It would be great for us at the beginning, right? Until everyone realizes what's going on. It's like, I can't mint DAI. I can't mint Link. I can't mint, like none of us can really mint more of these tokens, right? And we can't mint MKR or whatever. So wherever that token contract is, that original one, that's the origin chain. And it's a release or it's a lock functionality. On the other chains, we deploy what we call a synthetic or like a wrap token, as you might have heard in many other cases. And basically this has mint and burn capabilities, and it's linked. So it's linked to this, we link them to the origin chain, so where it came from. And basically all that happens is there's 0 on the mint and burn side, and we might have a total supply of like, let's say 1 million. Let's say we were to lock 100,000 tokens in the bridge, we would mint 100,000 tokens on this side. And then when you deposit them, we would go and burn those tokens. So total supply on this chain is back to 0. And then the total supply on this chain increases by 100,000, again, simply by releasing those tokens back into the wild. And that's the main difference, if that's clear.
Yeah. But in the origin chain, you would never have a burn mechanism then ever. Like it's not for security reasons, which makes sense. I mean, like I mentioned, for DAI, you would never have to like burn DAI. It doesn't make sense, right? But there's never been like an example that you would burn on the origin chain, unless, right, you want to like move tokens and just like leave Ethereum, right? I mean, that could be a possibility if you're interested in that.
Yeah, if a user is crazy enough, yeah, you could totally burn those tokens. It would cause some economic craziness for sure. The only example that's kind of close would be the I gapped it. Sorry. We can carry on. Oh, Ampleforth. There we go. Sorry. So the Ampleforth.
Oh yeah, the Elastic. Yeah.
Yeah, they have like an Elastic token, so it kind of is doing this, but that's again the nature of the token, and it's not ChainBridge, right? So.
Oh yeah, definitely. That's why I meant that, for a token like DAI or Maker, it doesn't make sense because the nature of the token is just like, it doesn't make sense at all. But yeah, I was wondering if there were other examples that you would have like a burn on the origin. Yeah, but like you said, Ampleforth could be a case. That's a good point.
Yeah. But yeah, otherwise, yeah, making sure you're minting and burning on the synthetic and locking and releasing on the origin. That'd be scary. Thankfully, though, by default, ChainBridge cannot burn things, even if that gets messed up in some sort of setup process, because it looks for the function burn. So that is a safety mechanism built in by default.
That's good.
Yeah, because we make use of this. We're not sending it to 0x0 or something absolutely insane. Also, for dApp developers out there, if you have something that burns tokens or something as a slashing mechanism, please just donate the funds instead. Send them to Gitcoin or something.
That's a good point.
Yeah, please. We do it in our audits. Anytime we do an audit and there's like a burn, we're like, please consider. We always make a note saying like, please consider donating to a cause.
That's a good point. Instead of just burning them, for sure. All right. Yeah. So we have like 10 minutes left. So what I'm going to do is that I sent the link of our ChainBridge documentation on the chat. Make sure you check that out. We're super happy that we implemented, a cross-chain bridge protocol like ChainBridge in Moonbase Alpha. And I don't know if you have anything else to add, Greg, or?
No, not from my end. I mean, if you do have questions specific to ChainSafe stuff, feel free to reach out to us. You can email us at info@ChainSafe. You can tweet us at ChainSafe's. It's a kind of a tongue twister there. We lost access to the original ChainSafe a long time ago. You can also hit us on our Discord for ChainBridge specific stuff. But yeah, feel free to reach out to us.
So actually what I'll do now is that I'll share my screen so I can check out the amazing UI you guys prepared. I thought it was like super cool because like the background is that when we implemented ChainBridge and Moonbase Alpha, we kind of like thought of a way of like making it accessible or like usable for like users, right? And to see how they can transfer ERC20 tokens back and forth. But there was no UI, right? So ChainBridge, well, ChainSafe, just to say it correctly, developed a UI for ChainBridge, and I thought it was like an amazing tool. And we're actually working to provide like a fully publicly available instance of this for our testnet, but sadly we don't have that right now. So what I actually have for you guys is a demo of this, right? So I'm sharing my screen. There you go. And as you can see, this is like a very simple UI. Do you see my screen?
Yeah.
Oh, all right, cool. This is a very simple UI that the guys prepared. It's super slick because it's very simple. All the magic is on the code that's behind all this. And the basic idea is that you can connect MetaMask to the UI, and you can see here that I have Alice in Coven, and I have like almost one Coven ETH or CAT or whatever you want to call it. And the bridge is configured so that you can transfer a set token, and in this case I have an ERC20 sample token that I created. And as you can see here that I'm in Coven right now, and I can click as a destination network and can select Moonbase Alpha. So what I'm going to do now is I'm going to send one token from Coven to Moonbase Alpha. And just to see, I'm going to show you the balance that I have on Moonbase Alpha. So this is MetaMask, and I'll click on Moonbase Alpha. And you can see that I have one ERC20 sample token in Moonbase Alpha, right? So let me go back to Coven, connect MetaMask, and I'll just send one token. I'll just say that I want to send it to my own address, and I'll just start the transfer. So right now what's going on is that MetaMask is asking me, are you sure you want to initiate the transfer? I'm going to confirm this. And the UI is going to like walk me through the whole process. It's going to be with me, like basically holding my hand and telling me, hey, this is how your transfer is going. Don't worry that it's working. So it's really cool. It's really intuitive, and it's really easy. I think the most important thing to mention is that it's really easy to transfer, in this case, ERC20 tokens from one chain to the other. I think, Greg was mentioning that the UX needs to improve, and I think this is one of the first steps into that direction, I think, right? So as you can see right now, I am waiting. It's in transit. We have only one relayer communicating Coven and Moonbase Alpha. So I'm waiting for that relayer to fetch the event on Coven, basically sign the transaction of the voting on Moonbase Alpha, and then execute the transaction on Moonbase Alpha. This, like Greg mentioned, this could take 2.5 to 3 minutes. So it's not instantaneous, as we would love that it would be that way, but the nature of the problem doesn't allow us to make this that instantaneous.
Yeah, and to kind of reiterate, why we can't make it instantaneous. It's not that we can't; it's that we don't want to. Similar if you use a centralized exchange, right? You'll always remember they have this block confirmation window. It's like, hey, we're not going to say you actually sent us tokens until 10 blocks goes by or 12 blocks. And that's just to ensure that there's no reorgs or, reorganization of the blocks, or perhaps like maybe some sort of like minute attack or anything that has happened. It's just to give like absolute confirmation that a certain amount of blocks is passed, and the probability of like the security behind the chain itself is, says after 10 blocks, let's say, we're pretty sure we're good. And in ChainBridge, we do about 10 blocks. So that's why it takes
yeah, definitely. Especially because Ethereum is probabilistic to finality, right? So I'm actually, this actually brings a really good question, Greg. What about if you communicate two EVM chains that have deterministic finality? What about that?
Avalanche does, I believe, 1 or 2 block confirmations.
Oh, all right.
Yeah.
Oh, that's the answer there.
Yeah. Yeah.
I'll be a lot
Yes.
faster, I would say, definitely. Yeah.
Yeah. Yeah. If you have finality, instant finality, in theory, you can do it right away. There's no problem with that.
Yeah, definitely. So as you can see now, the thing was signed basically, and now it's being executed on the target chain. And once this is done and it's the confirmation it's received, like Greg mentioned, it's probably around 10 blocks. Then we'll see as the transaction completed, and we'll check out our balance on Moonbase Alpha to see if it's 2. But yeah, definitely, that's a good point. When you have deterministic finality communicating with probabilistic finality, you have to pick the weakest chain in the link, right? Link in the chain, sorry.
Well, to be honest, now that we think about it, it's not about the weakest link in the chain. It's just for the specific chain itself, right? So I guess we have deterministic finality, and well, with Moonbeam, it's like we know it's final, right away.
Well, you need at least 1 or 2 blocks, and this is something we're working on. Like, we want to provide a way for developers to check the finality of the block. But once it's marked as final, that's it. There's no reorgs or anything that will affect that, right? So
yeah, that's the beauty of Substrate there. So I guess, yeah, in theory, you could probably drop this for any Moonbeam based interaction. You could drop it down to like 2 blocks, 3 blocks, and
Yeah, definitely. And when I was working with another project with the UI, the UI said, hey, we have to wait for 10 blocks. So the same as you mentioned, right? We have to wait for 10 blocks that go by so we can like say that this was confirmed. And I was waiting. It's like, hey, but I'm in Moonbeam. This doesn't apply to my use case, right? But the UI was programmed like that. So I guess it's something that needs to be configured for every specific application.
Applications should be worried too about cross-chain stuff as well. We're on a totally different topic, but with instantaneous block production too. So anybody that fast block production totally breaks a lot of time-based applications.
Definitely. Yeah, I got the transfer complete, so I can just go ahead to Moonbase to MetaMask, and you can see here that in Koban I have. Let me actually do something because it might look a little bit small. So let me actually expand the view. So you can see that I have now 3 ERC20 sample tokens, and if I go to Moonbase Alpha, I have 2. And I think it's just magic how it works, and it's I mean, with the interface especially, right? It's something that anyone without being a developer or anything, they can just do, and developers can leverage this as an idea to put this kind of like UI experience to their application. So yeah, that was pretty cool to share. All right, so I think this is time. Thanks a lot, Greg, for participating in the Builders Workshop. I think we had a nice discussion, you and I, with a few interesting questions. And I thought, honestly, it was a very nice presentation at a high level of explaining how the bridge works, because I think a lot of people don't really understand, how ChainBridge it's just a message passing protocol that it can be leveraged for like very generic applications. So yeah, thanks a lot for joining us. And yeah.
No, thanks for having me. Really appreciate it. And again, if anybody's got questions about what they can build and stuff like that, feel free to hop into our Discord. Similarly, the Moonbeam team is Alberto here leading charge, and I'm sure would love to see some creative applications built. So, if you got an idea, let's jam on it. And I'm sure one of our devs would be more than happy to kind of walk some people through some ideas.
All right, guys. Thanks a lot for tuning in, and I'll see you around. Bye, Greg.
Ciao.